What did we learn? What did we learn last class? So that's learn what? Balancing equations. How exactly do we balance an equation? Like, what are the steps?
Step 1 is to identify the reactants.
Identify the reactants and the
Products.
products. Good. What side is the reactant side? Left side. Right side is the product side. What's the next step?
List the atoms of the reactants and the products.
Very good. List all of the atoms in the reactants and the products. What's next?
Calculate the amount of each atom present.
Calculate the amount of each atom present. What's next?
Figure out which one is happy and unhappy.
Figure out which one is happy, which one is not happy. How do you figure out who's happy and who's not happy?
If it's the same, then they're happy.
If it's the same number on both sides, then it is the atom is happy. If you have the different numbers, you are not happy. How do you make them happy?
Balance them or add a
But how though?
coefficient.
You're going to add a coefficient. Now, in terms of counting, when you add your new coefficient, what do?
Multiply.
You multiply what?
The subscript.
Subscript
Coefficient.
by the coefficient. And if you have more than the atom present in 2 or more of your reactants or products, what do? If you have one atom in 2 reactants, how do you do after you add coefficients of one of your reactants?
You still got to go back and balance out the other. Add it.
No, it's the same atom.
You add it up.
You're
you
going
add
to
it.
add them together.
Okay.
Good. Once you have added all the coefficients that you need, what do you do then?
You don't you have to double check to make sure that everybody's happy still?
Once you make sure everybody is happy, what do you do after that?
You add the one to the ones that you didn't.
Very good. You add ones to the reactants or the products that you did not need to add an additional coefficient to. What's next? What else did we learn? Hmm?
6 polyatomic anions.
Very good. We have 6 polyatomic anions. What are their formulas and what are their charges? And their names.
Carbonate.
Say it again.
Carbonate.
Carbonate. What is the formula for carbonate?
CO3 charges 2 minus.
CO3 2 minus. What's the next one?
Sulfate.
Sulfate. What's the formula for sulfate?
SO4 2 minus.
SO4 2 minus. What's the next one? Phosphate. What's the formula for phosphate?
PO4, sorry. PO4.
PO4
3 negative.
3 minus. Good. What else was the other one? Nitrate. What's the formula for nitrate? NO3 minus. What's the next one?
Chlorine.
Chlorate. What's the formula for chlorate? ClO3 minus. Good. Yes.
To remember the electron charge on it, I guess is there like a trend to that? I feel like I asked you that last class, so it's just something you gotta know.
It's something that you gotta know about until you know where it comes from, and you're not gonna know where it comes from until we hit chapter 8.
Okay.
You're missing hydroxide.
Well, he interrupted us before we were finished.
Oh, my fault. OH minus?
OH minus, good, and that's hydroxide. What else did we learn?
Types of bonds.
Types of bonds. What are the 2 types of bonds that we have?
Molecular and ionic.
Molecular bonding and ionic bonding. How do we recognize a molecular bond?
The molecular bond is only between nonmetals.
It's only between nonmetals. Where do you find nonmetals on the periodic table?
The
outside?
On the right side.
On the right side. How do you identify an ionic bond?
It's between metal and non-metal.
How do you, between a metal and a non-metal, where do you find your metals on your periodic table?
On the left side too,
More than two.
on the left side.
Until there's like this.
The first two groups are alkali metal and alkaline non-metals. Those are the main, that more react with the non-metals.
Okay,
We have a transition metals.
very good. So you have your alkaline, earth metals, and then you have your transition metals, which is your rectangle and the first two groups. What is thinking electron-wise? What can you tell me about an ionic bond?
As the gains or loses the electrons.
Opposites attract.
Opposites attract. What is happening? You have a transfer of electrons. Now this ionic bond, what else can you tell me about the ionic bond? What is it really?
Metal give up electron.
Your metal is giving up electrons, and your non-metal is going to gain electrons. Good. But in terms of the type of bond that you have for an ionic bond, is it a bond?
No,
What is it?
it's basically just a thingamajig, but it's not. It's like I need you for something right now, so I'll use it now. But if there's something else, I can use that one too.
Right.
Yeah.
But now there's a name for that. What's the name for that?
Electrostatic interaction.
Very good. Okay? Ionic bond is actually an electrostatic interaction, which simply means opposites attract. Okay? Now what can you tell me about my molecular bonds?
It's a marriage.
It's a marriage, and what is happening in this marriage?
Sharing.
You are sharing electrons. Good. What else have we learned? Tafara, what you learn?
Are we beginning chapter 3?
I don't know, you tell me. What did you learn?
The law of conservation of mass?
The law of conservation of mass. What does the law of conservation of mass state?
What you put in is what you get out.
Okay, very good. What you put in is what you get out. Meaning that whatever comes in your reactant side, however many atoms you have on your reactant side, that is supposed to be how many atoms you have on your product side. Whatever mass you put in on your reactant side, that's how much mass you should get out on your product side. Okay? What else? You did balance and degree.
Naming binary compound.
Naming of binary compounds. Binary, what kind of compounds?
Ionic compound.
Binary ionic compounds. Okay? What does binary mean? Two. Good. And ionic specifically?
Ionic bonds.
What does that mean? You can't use the word in its own definition. Metal and non-metal. Okay? Now, in terms of naming my binary ionic compounds for your alkaline and your alkali earth metals, what do you do? What name? You keep the metal. The metal keeps its name. What else? What happens to the non-metal?
The three last letters change to I.
There you go. The last three letters change to "ide." All right? Now, if you had binary ionic compounds of transition metals, how do you name those?
I use a Roman letter.
You use the Roman numerals to represent what?
Their charge.
Their charge. Good. You must include that. Now what happens to your non-metal when you have a transition metal?
It determines the,
No. In terms of the names. So you told me for a binary ionic compound with your group 1 and group 2, the metal keeps its name and the non-metal now ends in I. When you have a transition metal and you have your Roman numeral in there, what happens to the non-metal?
You
That's why-
you put the die or something.
No.
ID.
It's the same thing. They end in I as well. Okay? Now, in terms of your 6 body atomic ions, when you're including that in your binary ionic naming, how does that affect? What happens to your polyatomic anion? Your polyatomic ions, sulfate, phosphate, carbonate, nitrate, chlorate, hydroxide. No, what? Well, they start off at 8 though. So what happens to them?
Ick. Did you say something? No?
But yeah.
Okay, so when you have your ionic compound, be it your alkali earth metals or your transition metals, when you're now adding your polyatomic anions, how is their name affected by now joining up in this ionic compound?
They stay the same.
They stay the same, right? The polyatomic ions, they keep their names. Now, in terms of, we have acids. We have binary acids. How do we name a binary acid? Yes, Rafa.
okay. It would be, hydro, the prefix,
Mm-hmm.
and then H.
Well, before we go there, what signifies that you have an acid?
Hydrogen.
You have a hydrogen in the front, okay? For right now. Go ahead.
So you put hydro.
Hydro,
You put the element.
the element, you say their name, and what happens to their name?
Suffix at the end of the name, which would be ick.
Very good. So you have your non-metal ending in ick. What else?
Acid.
And you have acid at the end. All right? So what is the acid for fluorine? Hydrofluoric acid, bromine, chlorine, iodine. Very good, hydroiodic acid. Now we have oxyacids. Yes.
Don't put the hydro.
You do not say the hydrogen at all. And what happens? Let's say if you have an oxyacid that ends in 8, changes to ick, and add acid at the end. If you have an oxyacid that ends in ite, how do we determine if something is an 8 versus an ite?
So, polyatomic anions, right? When you lose an oxygen or add an oxygen,
So when you lose an oxygen, what does it become? Ite. Good. Now, if you have an acid that ends in ite, what does the acid be? What does the name become? Us. Okay? Let's say if you have your 8s, you add an oxygen to it. What does your acid now become? Ooh, no. No hypo. If you add an oxygen per ick, right?
So per is added to anything that has.
No, if you start off at 8
Yeah.
and you can add an oxygen to your 8s, that now becomes per.
If you add an oxygen.
Yes.
So for all 8s, do you need to add an oxygen? Is that what you're saying?
It's not that you need to, it's that are you able to?
So some of them are not gaining oxygen.
Right.
Only
Okay,
the
so when
chloride.
it gains oxygen, it's per.
Yes.
And you said it was only the chloride.
Only chlorate can do that. Now, if you have an ite, if you lose an oxygen from your ite, what does it become? Hypoite. Okay? Let's see what else. We have our binary molecular compounds. What do we need to know with naming our binary molecular compounds?
Non-metal keeps its name.
The first non-metal keeps its name. What's next?
Second non-metal
Second non-metal
changes to I.
changes to I. And what else, Karen?
It gets a prefix.
It has a prefix. What are my prefixes? Give me the first five. Mono, di, tri, tetra, penta.
And the first non-metal never gets mono and fine.
Very good. If you have one first non-metal, you never say mono. But if you have one second non-metal, you must say the mono. Okay? What else? Was that it? Yes, no? Maybe?
There's no, that goes for the binary molecular compound.
Yes.
So if there's no metal in it and it's a covalent bond, the first still keeps its name, right? And it doesn't change at all, no matter what, just say the name. And you add two, or is it still the prefix? Because that kind of confuses me.
What do you mean?
The Roman numerals?
When do you add Roman numerals?
Well, it's a transition level, right?
Right, but you're talking about
Binary
molecular compound, right?
compounds that are covalent bonds.
Right.
So we just say the name straight?
You see, the first non-metal just keeps its name. Oh,
And the second non-metal,
second non-metal will end in "ide"
I.
and have a prefix. Yes.
I have a quick question because I'm kind of confused with the binary and the oxy acid. How do you know when it's which is which?
For which one? The binary ionic?
How do you know the difference? Like, how would you know?
Wait, in terms of the acids, or
Yeah.
okay. So let's say we have, we'll call out the binary acids for you. Hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrofluoric acid. What are those of? What are those? What
They
can you
all have
class?
hydrogen.
No. Your oxyacids have hydrogen as well.
Okay.
But what is specific about these acids?
It has egg.
No, not the names.
Halogen.
It has the halogens. Your binary acids are based on your halogens. All your group
The before-
7. Okay? Now your oxyacids, where does your oxyacids come from? Starts with a P.
Polyatomic ions.
Your polyatomic ions. That will always be your oxyacid coming from your polyatomic ions. And they will always have an oxygen in there.
Okay.
Right? What else? Anything else? Yes, no, maybe? However? Yes.
So the binary.
Which one? So, your binary acids will be acids of your halogens. Group 7. Your oxyacids will be acids of your polyatomic ions. You get that? That's it? Got it? No? Maybe? However? Anything else? Questions, comments, inquiries? You get it?
Yeah.
Alright, so we were finishing off our balancing of our chemical equations and our reading our equation in synthesis. Yes. Alright, so we did this one. Can I get this read in a sentence, please? Yes, go ahead, Keith.
potassium hydroxide reacts.
Aren't you missing something?
Oh, you have the numbers there? The numbers ain't up there. Oh, wait, you talking about the unbalance? Or the Alright, you see, I can't read the balance one. I'm sorry.
Why?
The light.
Mm-hmm. See, my students got me. Yeah, you could roll now, so come, let me roll.
3 atoms of potassium.
3 what?
3 molecules
Uh-huh.
of potassium hydroxide reacts with 1 molecule of hydrogen. Whoa.
Ooh.
This
That's my. This is an oxyacid,
Phosphoric acid
phosphoric acid.
Yeah.
to create
Uh-huh.
1 molecule of potassium phosphate
Yes. And
and 3 molecules of water.
very good. We did the second one, right?
Oh, yeah.
So let me get this in a sentence. Who's it gonna be? Who's it gonna be? Talia.
2 molecules of potassium nitrate reacts with 1 molecule of carbonic acid
Good.
to produce 1 molecule of potassium carbonate and 2 molecules of
Nitric acid. Very good. Now, last one we didn't do. So can I get this in a sentence? You might want to help me out?
That's it's X mole of potassium phosphate. Sorry, sodium phosphate.
Uh-huh.
Reacts with X mole of the hydrochloric acid.
Very good.
To
produce?
that produces sodium chloride, X mole of sodium chloride.
Very good.
X mole of hydrogen phosphate.
No!
Phosphoric acid.
Very good. Now, balance my equation, please, and thank you.
All right.
Do we need to do it on the board?
You gotta list it.
We gotta do it again?
You gotta list it.
Okay.
HCl is hydrochloric. What is HClO?
Hypochlorous acid.
You're right.
And stop
I
cussing!
apologize.
Professor, I got a problem with
What
the
you got a
homework
problem
because
with?
I wrote it right and it kept telling me wrong.
What you mean? Who
For
told you
the-
wrong?
Can you write out nitrate?
Nitrate?
Yeah.
What's the formula for nitrate?
Isn't NO 3 minus or something?
Uh-huh.
Yeah, but they told me that was wrong.
NO3 minus or
On the homework?
I did capitalize. I did it like 4 times.
But did you subscript the number? And
I did.
And
Press little
superscript?
X thing Majid.
And superscript the sign?
Yes.
Did
Oh
you
God.
Oh.
Did you do the? Does it matter if the minus sign is before or after?
What minus
It
sign?
was after I put the 3 down.
You know, like
at
when
bottom
you do the
of
superscript.
Oh no, like it'll come up as the correct thing.
Oh, okay.
Do you put the 3 at the bottom of the?
Yes.
Oh yes, I did that like 4
On
times.
the
Yeah,
the right-hand
and I
side?
did N-O, the tree, and then the dash, and it's still telling me wrong. I did it like mad times. I was like, forget it. They only gave me half credit for the 2 that I did in the top. Those 2 in the middle, it would not give it to me. And I'm like, what am I doing wrong?
Why you ain't email me?
I
Did
don't
you
know.
just
See,
I only left half of it. I only did the 2 and then I just left the other 2 because it was not doing it.
now
for me.
remember, Sapling is finicky about how it wants its stuff inputted. So if you're having an issue with it, shoot me an email so that I'll be able to open up your stuff and check it to make sure that you're actually doing it right. Yes, I have access to your homework. I can see what exactly you're doing.
Well, you're gonna see that I did it like 100 times.
Does Sapling care about significant figures? 'Cause
Yes,
I
it
don't
does.
want
Yes, it does.
Really?
Oh, yes, it does.
It does.
It will give you a big fat 0 if you have the right number, wrong number of significant figures. All right, let's go. What we have here?
Sodium.
P, phosphate, oxygen.
Oxygen.
What happened?
Phosphorus.
Phosphorus, not phosphate.
My bad.
This is phosphate.
Oh, okay. Oxygen, hydrogen, and chlorine.
Another 3. And then a 1 in front of it.
Got 2. Can I get a sentence? Serena? Don't be looking around.
1 molecule of sodium phosphate
Yes.
reacts with 3 molecules of hydrofluoric acid
To produce.
to produce 3 molecules of sodium chloride and 1 molecule of phosphoric acid.
Yes. Good job.
I have a question. So first of all, we have to reach for sodium, right? And then for the hydrogen,
Yes.
right? Is it like every time like this?
Yes.
So it's the first one and then the second one.
What do you mean first one?
And then, for example, for the first example, right? So first of all, we have to balance potassium and then again hydrogen, right?
Yes.
Okay, so let's say on the exam, if you don't include the coefficient 1, will it still be wrong?
Yes, ma'am.
Not even half a point?
Not even half point. Do the whole thing wrong. Because think about it. If you had these questions, well, you will have these balancing as multiple choice. If you choose one that doesn't have the ones, you will be incorrect. Right? So you must show me that you know that there's a 1 there, and this way I can be confident in letting you leave them out. Because you will be able to recognize on the final that yes, that has to be a 1. Tell me.
On the homework, right, I was noticing that there was a question like magnesium plus a molecule of oxygen gas, so Mg plus O2. Now, I was confused because it makes magnesium oxide
Yes.
instead of carbon dioxide and water, but then I realized it's because it's not a hydrocarbon, right? That's why it's not a combustion reaction. But then when I went online, a lot of like other chemistry professors was like, it could be both a synthesis
No.
and a decomposition.
Okay. So don't you tell me that's
Not
what you go.
composition.
Thank you. Yeah, it caught right here. Clear that out. Okay. So a combustion reaction is normally between, which again you'll see just now, between a hydrocarbon and oxygen gas to produce carbon dioxide and water. So,
No.
Oh, okay, so, but one of the significance of your combustion reaction is the release of energy, right? You have a release of energy in the form of heat. With magnesium and oxygen, you also have a release of energy. But this is a release of energy in the form of light. So this is why they're saying that it is a combustion reaction, because you have a release of energy. This is why it's combustion. But in terms of what combustion is, no, it's not. It's a combination with a release of energy.
So,
Get that?
if I ever ask that on the exam, just put synthesis, don't put synthesis and combustion.
Yeah, no, don't you put combustion. We have a definition of what combustion is, and that ain't